Good morning everyone. Welcome to ibphysics.com. And today, on this auspicious day of Dhanteras or Diwali, I thought of extending my program from IB to MYP also. So towards it, what I am doing currently is only about giving one problem per day, because there was a lot of demand from the MYP students, and like there are not much of textbooks, and as a result of it, they all said it would be better that if we have something like a revision exercise, it would be a better one. So as a result of it, I thought, so why not I extend this, okay, so to MYP also, but of course continuing with my IB. To begin with, so today we are beginning with this. So every day I'm going to post one problem on each criteria. So maybe today if I'm doing on criterion C, then criterion B I'm doing, and maybe tomorrow I will do it criterion C, and then on criterion D, A, and so on, so randomly. So all this would be updated in my website. So as you know, my website has already been updated. It's totally changed because my previous vendor, whom I was which I was using to design the websites, it was not so good. There were lots of what you call discrepancies, glitches over there. Sometimes the site never used to open. There were many complaints which had been seen for the past 3 months. So I thought, okay, switch over to a new platform. So I switched over to a new platform, and as you know, we have 3 websites. So the first one is my homepage, and that is also being completely modified. And the second one is this IP Physics with Rao. And the last one is prayogashara.com, which I hope many of you have already worked on it and looked into it. And this website is something like related to my passion, or maybe related to the experiments that I do conduct. As a science teacher, if I do not conduct any experiments, I don't feel the importance of it, of science, or I will not be happy with it. So I thought, okay, why only students should do it, even I should also do something. So as I keep on upgrading myself, I thought I will also do something. So as a result of it, I made some experiments. So you can also go through it. Anyway, so now today we will continue with this. So you can, maybe in the description I'll put it across the URLs of this. Many of you have already used it, and do support me and encourage me in doing this. Thank you. Okay, now let us begin with this. So today we are working with criterion B. So criterion B, as you know, is already about the design of an experiment. And criterion C comes to data analysis. So we'll do data criterion B, and later on we'll go to criterion C. Okay. First question goes on electricity. A resistance is an electrical component that limits the flow of current in the circuit and converts electrical energy to heat energy. Okay, as we know, resistance is the opposition given to the flow of current, and also it helps us to convert electrical energy to heat energy. More the resistance, more the heat energy that you get. Resistance can be measured using an ohm meter. Okay, that's also something which is known to us. Now this is what is shown over here. There's a resistance, there's a material which has been kept over here. You have an ohm meter. You are measuring the resistance of it, and this is seen to be 12.2 ohms. Okay, let me move on. A student is interested in studying resistance. They decide to model resistors using cylinders of conducting material. Okay, so they want to study resistance, and they are using resistors conducting to using cylinders to decide the resistance. What is the relationship between the diameter of a cylinder and its resistance? We are relating diameter with the resistance, and formulate a hypothesis to test this research question. You are going to formulate a hypothesis. This is a question. Now, question here once again is so you need to formulate a hypothesis. So how do you formulate a hypothesis? So you can now say the resistance. Okay, as we know from theoretical point of view, the resistance is given by rho L divided by A. Right. So what is this A? A is the area of cross section. I can also write this as rho times L divided by pi r square. So what does it tell you? R is nothing but radius. So therefore, from here what we can say is that R is inversely proportional to d square, because you know R is equal to D divided by 2, I can just say R is proportional to 1 by D square. That's what we can say here. Okay, now let us read the next question. So this is what you need to write. So this is your equation I have written, but I need to write a hypothesis. Only then you will get a mark. Okay, let's see how much mark does this carry on. Just give me a moment. This is for 2 marks. So how do you formulate a hypothesis? You should just say that the resistance is inversely proportional to the square of the diameter of the cylinder, right? So as the diameter increases, the resistance decreases. So I will write it down if you want. I can say if the diameter of the cylinder increases, then the resistance decreases as resistance is inversely proportional to the square of the distance of the diameter, not distance. Okay, so remember, you should write it appropriately. Do not just say, okay, that's proportional to diameter, and just don't write the equation. You should completely mention it, only then you'll get the full marks for it. Okay, now next question. So here, select the cylinders that the student should be able to collect appropriate data by dragging the cylinders from the box onto the table. So what I have done is, this was available in some access prep, so I will not be able to project the access prep over here, but instead I have just convert this into a Word, and as well as I have converted this into a PDF. So as a result of it, I will not be able to drag it. But when you are doing an e-assessment, definitely you will be having something like a cursor here, and you will be able to drag. Now let us understand what is that you need to drag. So select the cylinders. The student should be able to use the appropriate data by dragging the cylinders from the box onto table. Now, how should the dragging take place? That's the next question which you ask. Let us read the question carefully. What is the relationship between the diameter of a cylinder and its resistance? Okay, so diameter and resistance is what we are going to vary. Now here you see, some cylinders are lengthier, some of them are shorter. Okay, which means what? What are the variables? Let us write down the variables over here. In the cylinders, one is the length. Length is varying in the cylinder. The second variable is that, see, some are having a different color. This is having something like a different color. This is different color. This is different color. Which means what? There are 3 types of cylinders. Which means what is changing? The type. What do you mean by type? Type means the material is changing. When material is changing, what else can change here? The resistivity can change, right? So many of may think it's density, but when it comes to electricity, what is that you need to require? You need to look at the resistivity and not the density of the material. Okay. Now we have seen length, this one, and then what is that you need? Diameter. Now what else you see here? Some of them are thinner in size, some of them thicker in size, right? Okay. So therefore, diameter, area is also changing. In other words, diameter is also changing. So what is that we need to require? We need to see to it that the diameter should change, but the material should not change. Material should not change. And what about length? Length also should not change, right? So this is what we need to take. Now, so how do we select such that, so it's only, we need to find only these two. So length should remain a constant, diameter and resistivity can vary. Now, can I take, if I take this cylinder, this cylinder, this cylinder, let me take up only one color. If I take this color, for example, okay, and an orange one, see, this cylinder and this cylinder has almost the same length, and all these are having different lengths over here. Okay, but the area of cross sections are all almost same. You see, area, everything is area same. So I will not choose these colors. Now what I should say? I should look for the thickness and thinness, right? Thickness and thinness. Let us look at this. So in this color, I should not be able to select any cylinder. Now in this color you see this is thin. Let me write thin as small t. Then this is thicker. Let me write this as a capital T. This is thicker. Now what about this? This is much more thicker. I'll write this as double T here. Double T here. See, thicker, thinner, thick, double thicker. Right. So I can always use 1, 2, and 3. Okay. Now what about here? Okay. So here, what about the length here? See, this length, and this length, almost all the 3 lengths are same. If you look at this here, that is not seen. See, this length is very shorter. This length is a bit longer. So therefore, I think this would be the best one. I need to take the silvery one and then drag it on. Okay. So this is only to show you, okay, which of these materials can I choose over here. Okay. Do not just choose anything randomly. See to it that, okay, you are going to select only those. That is, the resistance will vary with the thickness only, not due to the length or due to the type of the material. So definitely most of them will do type of the material. Okay, they will take only one material, but you might select, some of you might select the orange, yellowish orange one, or maybe the black one, but don't choose this one. You should only select the silvery one. Okay, now let me move on to the next question. Okay, so you're going to take material B here. Material B. Next, sometimes my screen is glitching on and off. Let me check it out in the next session. What happens? Why should it glitch like this? And then get back. But anyway, for today, let us continue with this. So, having carried out one trial for each cylinder, student records the data as shown below. He records data like this. What is the data here? 27 millimeter diameter, 12 ohm resistor, 12 millimeter, 56.2, 17 millimeter, and so on. Now, do you think this data is good? I don't think this is good, because you know. So initially 27, then 12, then 17. You see, haphazardly here and there they have put it across, right? So it's very chaotic in nature. I don't want something like this. If I am doing an experiment, it should be very systematically ordered. Okay, now let us read the question. Okay, so what does it give here? So it tells you organize and present the data in the table. You need to organize. So what do you mean by organize? How do you organize? Put the data in an increasing one. Okay, first one. Now what all things that you need to put it across? So let us put a table here. Put the table here. There's space, but anyway, I'll just try to squeeze it inside this. So first one is, I will write a cell number. Every table will have an SL number. Without an SL number, no table exists, right? You should have a SL number. Then what is that you are going to vary? You are going to take the cylinders, you are going to measure the diameter of it. What's your independent variable here? The diameter is an independent variable. So diameter should be your independent variable. Diameter should be your independent variable. How are you going to measure diameter? You are going to measure the diameter in millimeter. What I will do is, I'll have this one. I'll write /millimeter. Okay, first I should write the headers, and after that I will populate all the values. Okay, and then after this, what I'm going to do? I'm going to calculate the resistance. How do I going to calculate the resistance? The resistance is in ohms. So I will write this in ohms. Complete the table. Now what is that I have done? I have drawn on the skeleton part of the table, an empty table with the necessary headers and the necessary units over it. This is very, very important to do this. Okay, next. What's the next thing? Now, see, when we write a table, okay, first what we'll do is we'll take the first reading. Now take up the one which is having least value in diameter. Which one has least value? 12 millimeter has a least value. I'll write 12 here. Do not write millimeter once again here. Just write only the values. And what is the resistance here? 56.2. 56. Then second one. What's the next value? More than this one. After 12 you get 17. Right, 17. And what is the value here? 27 ohms. 27. Then third one. What's the third one? Third one. Right. Just a minute. Let me extend this. Yeah. Third one. After 12 we have finished. 17 we have to just tick mark this. 12, 17 is done. And 20 millimeter. 20 millimeter. And resistance is 20 ohms. Good. Fourth one. What is the fourth one? Fourth one is 23 millimeter. 23 millimeter. Resistance is 16 ohms. 16 ohms. And then fifth one. In fifth one, what is 51? 27 millimeters. 27 millimeters. Resistance is 12 ohms. Right? Now what is the trend you can see? You see 12, 56.2, very high, lesser diameter, higher resistance. Then the diameter keeps on increasing. The more the thicker it becomes, then what happens? The resistance keeps on reducing. What do you understand from the data? You understand that when the diameter increases, the resistance decreases, right? This is what you call as a trend line, and you should know this particularly, right? Now let me move on to the next one. So this is for, I think, for 4 marks, right? This is for 4 marks. See the way how it is organized is, so the headers along with the appropriate units, this will carry 2 marks, and this will carry 2 marks. Okay, so many of them in an urgency, what they do is that they only mention this one and they forget to mention this, or maybe they will write millimeter here, ohms here, and they make it a mistake. So that should not be done. Remember, it should be done in a very systematic way, because we are looking at the design of an experiment. How do you design your experiment? That's what is your interest over here. We are not looking at the data analysis. Okay. Next. Move on to the next question. 2 marks. The student's lab partner wants to carry out more trials. Suggest how this would improve the investigation. 1 trial is sufficient. Why do you want to carry more trials? Right? See in the table. How should the table will now look like? The table would have looked, usually when you conduct an experiment in the lab, this would have looked something like this, right? So this would have been R1, this would have been R2, this would have been R3. Then you will take R mean, right? You take the mean or the average values of it, and finally you will calculate what is the average. Now, why do we need to do it? Why should I waste my time in doing this? That's a question over here. Okay. Suggest how this would improve the investigation. So when you do this one, first one is, see, you are conducting an experiment using electricity. When you do it with electricity, there is a possibility the connectivity issues are there, or maybe as time proceeds, okay, since electrical current is passing through it, the resistance might get heated up, and as a result of it, the element might get heated up, not resistance, element will get heated up, the resistance will also increase, right? So therefore, it is always better to do multiple trials to reduce randomness in the experimental readings. This is the first reason why we need to conduct it. Usually when we come to IB, we do something called as an internal assessment. There you need to actually conduct an experiment. When you conduct an experiment, we expect you to do at least something like 5 trials and take the mean of it. This is one of the reasons I can say. The second reading is that, now let us say while you are conducting the experiment, you have got values like, after you do multiple trials, first time you get something like around 27 ohms. Second one, you get 27.2. Third time you get 27.5. Fourth time you get something like 26.8. Fifth time you get 22 ohms. Now what do you see here? You see this is an outlier over here, right? So therefore there is a possibility that you might get this. So when you get this, okay, and then you immediately consider this would be wrong over here. So what you do is, you can say out of the 5 trials, one of them was an outlier, so I reduce this. It is something like, now why is an outlier required? Okay, let us understand this also. Let us say for example, you have a dartboard. You know what a dartboard is, right? You take a dartboard, you take arrows and you hit it across. You take dartboards, right? And then you hit it across. So what will happen? First time you hit it here, second time you hit it here, third time you hit it here, fourth time you hit it here, fifth time, let us say it goes outside the board. Now, how do you say what is that you are good in? You can say, maybe, see, most of the time I was hitting over here, I was very consistent in it. Maybe I can ignore this, right? This is what you call it as an outlier. This is what you call as an outlier. Okay, you might get one outlier, ignore that part, doesn't matter, and take wherever it is consistent. Okay, to understand. Okay, so is there any type of error being presented, or to eliminate the outliers? So we use this one. In fact, there is one more reason for doing this one. Okay, is something like by doing multiple trials, we get to know whether there is something called as a systematic error. Systematic error. What do you mean by systematic error? Now let us say for example, I want to measure the length of this pen. The length of this pen would be something like around 22 centimeters. Okay. I take a scale for example with me and I measure this one. Okay. So unknowingly I measure this one, I say it is 25 centimeters. Why should it be 25 centimeters? The reason could be when I put this 0 here, the 0 of it may not exactly coincide with this tip over here. Maybe 1 centimeter or 3 centimeter would coincide and I would have not even noticed. Or maybe the scale is broken and the 0 of it was not there and 3 centimeter was the origin. So as a result of it, I would make a mistake. Now anything that I measure, I will always get 3 centimeter more only. Okay. So in order to understand, this is what you call systematic error. Okay. If you do multiple times this one, then every trial that you do will always be increasing by 3 centimeter more. then I can understand, oh, there is something wrong with this, right? This is a systematic error. In a similar way, okay, so here also you'll be able to understand that. Okay, let me move on to the next one. The student draws 4 graphs using the data from part D. Select the most appropriate trend line to show the relationship between diameter and resistance. Now we have already seen from the table, what did we see? As the diameter increases, the resistance started to decrease, right? Now which of these graphs mimic that particular data? Let us look at this. See here, you get something like 10, 11, 12, say it's 15 here. This could be 12. For 12, how much is it? It's something like 50, 56 over here, right? Let me go back to this and see what is the data here. For 12 centimeter, 56, correct? 17, 27. 17, 27. 17, 27, 26 is there. Okay. Then third one, 2020. 2020. 2020, where is it? 2020 is correct. And then 23, 16, 27, 12. 23, 16, 23, 16, 23, 16, and 27, 12. All the points are correct here. Now, what about this graph? Okay, and therefore, he has joined over there. What about this graph? This graph also, the points are exactly there. The line is going like this over here. Now, he is asking about the line over here, not about the points. Everywhere the points are correct, I think. We look at the next ones also. Okay, points are correct only, but it only depends upon which graph we have to select over here. So, should we select this? Should we select this? Or should we select anything over here? Now, if you look at this graph has a straight line over here. Okay, and then you go like this over here. Now, let us look at the points over here. See, here you are putting it across over here. So, this should not be done. Okay, because if I take for example at 16, I should get 17 for example, I should be getting this value, but this line does not fall onto this point over here. So therefore, this is definitely wrong. Do not model everything only with a straight line. There's also a possibility, but some of them could not be a straight line. It could be a curved path also. So therefore, I will always say B is incorrect. And let me go on to the next one. So here also you see, most of the time it is now falling somewhere over here. It is not passing through all the points. So this is also incorrect. Now amongst B and D I should decide. B, there's a straight line, and there are always straight lines everywhere. Okay, but in D, you have a curved path. Okay, see, when the variation is not known to us, do not always over predict saying that this should be a straight line, because I do not know how does it predict, how does it go here, right? This can also go by any other means. So therefore, this also I would not go about it, but I would always go with the curved path. So D is my right answer. Okay, we can move on to the next question. The student wishes to extend the investigation by using the same materials and equipments available in part A and B. Dependent variable would be resistance. Okay, he has not changed the dependent variable. State an appropriate research question. Research question RQ you need. Then you need your IV and one control variable, because this is your DV. It's already known to us. Okay, so you want to change something. So this part of it is your criteria and C. I'm not going to do this one now. I'll do it in the next video probably. But this one will do with this. Student wishes to extend the investigation with the same materials. So you need to design a new RQ, which is of 3 marks. Now what is that we will select? So what did we select earlier? We selected the independent variable to be diameter. Now what all is left for us to do? We can either choose the length or we can choose the resistivity. But he is already telling you that here, student wishes to extend the investigation using the same materials and equipments available, and you can choose, okay, so you can choose any one of them. You can either choose length or you can choose the resistivity. How do I go about it? Okay. So the better one would be, I will go for the length one here, because he is asking you for one research question. I can say, since R is equal to rho L divided by A, what I can do? I can choose as R increases, then as L increases, R increases, provided that area and resistivity are seen to be a constant, right? Now, can we do this? Because you can frame any question, but you should see to it that, okay, there is appropriate methodology or materials available for you. Let let us go back to this. So what do I need? What are the control variables here? I have the control variables to be area and resistivity. Let us look at that also. Area and resistivity. I need to have the same type of area. Cylinders which are having same type of area. Do I have cylinders which are having same type of area? Of course, here we have same area, same area, same area, same area. Resistivity is also same because same type. What is changing here? Length is changing. See, there's a smaller length, bit larger length is very large over here. Okay, there's a moderate length is much larger over this. So definitely you will be able to conduct an experiment using this. Okay. So with this, I think we have come to an end to criterion B, which was for 17 marks. So in your comment section, you mention me if you are able to do this one, because what I'm going to do is today I will be uploading the question paper and the solution for this will be available only tomorrow. Okay. So first try doing this question paper, and if you still do not get it, then look into this. So thereby it is something like a test that is being conducted to you, and then next day you view this video and understand which conceptual places you have missed it. So what you can do is actually you need not view the full video. You can actually put it in a 1.5x and then you can proceed, because this is taking a long time. This is only for 17 marks and I should expect someone to complete this paper in 17 marks. But since I started explaining, it would have taken more than half an hour to do it. Okay. So what I expect is go through the paper, first you solve it and then look at the solution and then keep on moving forward and then see whether you have got the same answers or not. If you have not got something, then look into the explanation. If you still want to go through the full lecture, you're always free to do it. Okay. Thank you friends for looking into it, and tomorrow we will see with one more criteria paper.